Hello, today we are going to learn how to rewrite a radical or square root in simplest form. To rewrite a square root in simplest form, we need to make sure that there are no perfect squares other than one that divide evenly into the number that's under the radical or square root. All right, so radical is another term for a square root. There's also a lot of other roots, but for our purposes, we're only going to deal with square roots. We learned about square roots earlier in the year when we were working with difference of two squares, and even before that when we were looking at rational and irrational numbers. Certain numbers are perfect squares, meaning that if you take the square root, the number will be a whole number, which is rational. So these numbers are very important to know, your perfect squares. So what we want to do first is make a list of all those perfect squares. So let's do that. So to do that, we would just start squaring numbers. So 1 squared would be 1. 2 squared, 2 times 2, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. I can keep going. I'm going to just write ... because I can keep going. These are what we call our perfect squares. So we need to know these perfect squares in order to simplify a radical, which we're going to learn how to do today. I would write that list down. So there are several steps in simplifying a square root. Now, if the square root is a perfect square, it's easy. Let's say you're doing the square root of 64. It would be 8, because 8 times 8 is 64. The square root of 100 would be 10, because 10 times 10 is 100. These are for perfect squares. But if we are asked to simplify something like the square root of 18, that's not a perfect square. If I were to do that in my calculator, I would get a decimal. So rather than doing it in the calculator and getting a decimal, which is an approximate value, we are going to rewrite it as the product of a whole number times a radical that is already in simplest form, meaning that there are no perfect squares other than one that go into it. So our first step is to find the largest perfect square that divides evenly into the number that's under the square root or radical. So we have to think of numbers on the perfect squares list that go into or divide evenly into 18. Well, 25 is too big, so is 36 and all those numbers. So let's start with 16. 16 times something to give me 18, that doesn't work. Right? It doesn't divide evenly. But 9 times something to give me 18, yes, that goes in evenly. It goes in 2 times, right? So what I would do is put my perfect square 9 on the left, and then my non-perfect square 2 on the right. So the square root or radical 18 is equal to the square root or radical 9 times the square root of radical 2. All right, so I would rewrite it that way. Now, the square root of 9, I can simplify to 3. That's a whole number. But the square root of 2 I cannot simplify, so I'm going to bring it down. So actually, in simplest form, the square root of 18 is equal to 3 times the square root of 2, or 3 radical 2. On this page, we're going to look at a few more examples of how to simplify a radical that is not a perfect square. All right, so for example, the square root of 24, not a perfect square. But if I look at my perfect squares list from the previous slide, the highest number that goes into 24 evenly is 4 on that list. So radical 4 times radical 6 would give me radical 24, because 4 times 6 is 24. Again, I can't use 12 and 2. Those are not perfect squares. Or like 8 and 3, not perfect squares. It has to be that this number here is a number from the perfect squares list. So now that I do that, I take my square root of 4, which is 2. My square root of 6 is not 3. Careful, it's not a perfect square. Square root of 9 is 3. So that I would just leave alone. So the non-perfect square always stays the same. So if I simplify the square root of 24, it's going to be 2 times the square root of 6, or 2 radical 6 is how we would say it. Okay, another example here is the square root of 160. Again, if I look at my perfect squares list, I have to look and see what numbers would go into 160 evenly. It doesn't look like there's too many, but I actually can see that 16 will go into it evenly, because the square root of 16 is a perfect square. It goes in 10 times. All right, so again, I do the square root of what I can. The square root of 16 is 4. The square root of 10, again, it's not 5. It's not a perfect square. So I would leave that alone. So the square root of 160 can be simplified to 4 radical 10. Again, radical just means square root. Some radicals cannot be simplified. Let's say we're looking at this one here, the square root of 17, or radical 17. If I were to look at a number on the perfect squares list, the only number that would go into it is 1. So if 1 is the only number that goes into it, it actually cannot be simplified. So you would be done. You'd be like, okay, that's my answer. Let me show you why. If you were to try to simplify it, 1 would be the perfect square, and it would be 1 times itself, radical 17, to give you 17 back. Now, the square root of 1 is 1. And the radical 17 would stay the same. Now, 1 radical 17 really means 1 times radical 17. There's really a multiplication there. 1 times anything is itself. So we're back to where we started. See that? We're back to where we started. So anything that has, any radical that has no perfect squares other than 1 that go into it is already in simplest form. So you cannot simplify it further. You must just leave it alone. And so that's pretty much it. That's how we simplify radicals. Again, if you have any questions, please feel free to reach out and I can explain this to you further and clarify it.